So this is going to be the first of 3 videos on moles. We're still on CC9 calculations topic, and it can come up on paper 1 and on paper 2. In this video, I'm just going to explain how to calculate moles, and in a later video, I'm going to explain what moles are, or more so why they're useful. But this video, I'm just going to focus on actually calculating them, because that's a really straightforward calculation. So there's a formula triangle that you would have to learn. Okay, you've got mass on the top, formula mass, which we've covered in a previous video, and then moles on the bottom. If you're not comfortable with calculating formula mass, go back and look at the second video from CC9 where I go through formula mass in detail. Okay, you can't calculate moles if you don't know how to calculate relative formula mass. Okay, so using this formula triangle, there are 2 equations that you're going to need to be able to use. So mass, okay, if you're using a formula triangle, you cover what you're looking for, and what you're left with is the formula. So if I wanted to find mass of something, it'd be the formula mass times the moles, and the other formula I'm going to be using is moles itself. And if I cover moles, I'm left with mass divided by formula mass, and that's going to be my formula for moles. Moles equals mass divided by formula mass. Okay, so if we look at some examples, we can see how this can be used. So let's say, for example, you were asked how many moles, so that's going to be the same for all of these questions. How many moles do you have in, let's say, 30 grams of sodium? Okay, so moles is mass divided by formula mass. I'm given mass in the question, 30 grams, so it's going to be 30 grams divided by the formula mass of Na. If you look at your periodic table, sodium has a mass of 23. In this case, in my formula, I've only got 1 sodium, so it's going to be 30 grams divided by 23, and 30 divided by 23 is 1.3. So I would have 1.3 moles if I had 30 grams of sodium. Okay, if we look at another one, how many moles would you have if you had 50 grams of CO2? Okay, so again, moles equals mass divided by formula mass. Mass I'm given in the question, it's in grams, so it's going to have 50 grams divided by the formula mass of CO2. So I'm going to have to work out the formula mass of CO2. Carbon has a mass of 12, oxygen has a mass of 16. Okay, you've got 2 oxygens, so it's going to be 12 plus 16 plus 16 equals 44. Okay, so that 12 is coming from the carbon, the 2 16s, CO2. So formula mass of CO2 is 44, so it's going to be 50 divided by 44, and I get 1.14 moles of CO2. Okay, I'm just going to do one more example. Let's say they asked you how many moles did you have in 100 grams of NaOH. Okay, moles equals mass divided by formula mass. Mass I'm given in the question, 100 grams. Divide that by the formula mass of NaOH. You're going to have to work this out. So from the periodic table, sodium has a mass of 23, oxygen is 16, hydrogen is 1. Okay, I've got 1 sodium, I've got 1 oxygen, I've got 1 hydrogen. I add all that up and I get, what do I get? I get 40. Okay, so from the Na, the O, and the H, formula mass is 40, so it becomes 100 divided by 40, and that is 2.5 moles. Okay, so I'm going to give you 1 or 2 to practice for yourself. Okay, again, really important that you're comfortable with getting relative formula mass. If you're not, watch a previous video. So I've got some practice questions for you here. Let me just zoom in on them slightly and refocus. Sorry. I'm going to refocus. So I'm going to ask you to do the following. You don't need to do all of them. Do question 2, do question 3, do question 5, do question 6, and do question 7. So do 2, 3, 5, 6, and 7. Your formula is up here. Moles equals mass divided by formula mass. And you're gonna, in question 2 and 3, I've been quite kind. I've already given you the formula mass, but in question 5, 6, and 7, you'll need to use these mass numbers, calculate formula mass yourself, and then use this equation. So press pause, have a go at doing those 5, and press play when you're ready to see the answers. Okay, so here are the answers. In question 2, you're given the mass 12, you're given the formula mass, so it's just mass divided by formula mass equals moles. 3 is the same, mass divided by formula mass equals moles. In 5, you actually have to calculate the formula mass yourself, so I've given you K2O. Now I have there's an error here, that the atomic mass of potassium is not 19, the atomic mass of potassium is 39. I've used 19 because I'm assuming that you all did, so I have 19 and 16 for K2O, giving me a formula mass of 54, and I've done 100 divided by 54 is 1.85, okay? However, that should be 39. So you should really have 39, and 16 calculating your formula mass. But because I've made a typo, you would obviously not be penalised if that was a similar situation in the exam. Just use the numbers that you were given. In question 6, I've got the mass. I need to find the formula mass. I've got 2 hydrogens, 1 sulfur, and 4 oxygens. When I add up those individual masses, I get 98. So it's 360 divided by 98. And then in question 7, I've got the mass, 0.45. I need to find the formula mass. So I've got 1 calcium, I've got 2 oxygens, I've got 2 hydrogens. The formula mass is 74. And then 0.45 divided by 74 is 0.006. Again, if you're not comfortable with formula mass, go back and watch the video about formula mass. As well as finding moles, you can also rearrange that equation. So if you remember, we said there was 2 equations you could get from your triangle. One was for moles, which we've just been using. The other is for mass. So formula mass times moles equals mass. So the other way that they can kind of ask you this is that they'll give you the number of moles and they want to find the mass. So mass is moles times formula mass. I've got the number of moles, I multiply by the formula mass, and I find the mass. So if I were to do the first one for you, it would be 3.2, my number of moles, times the formula mass. Well, it's just iron, so it's got a mass of 56, and it'll be 3.2 times 56 equals 179.2. So again, have a go at 2, 3, 4, and 5. Again, you will have to work out your formula mass. Once you know the formula mass, you just multiply it by the number of moles. That will give you your mass, and your mass will be in grams. So have a go at 2, 3, 4, and 5 yourself. Okay, so the answers for 2, it's going to be 0.8 times 111 is the formula mass of CaCl2. You get 88.8 grams. You've got 8.75 times 74.5 for KCl, so I've got the right atomic mass for potassium this time. You get 651.88 for number 3. For number 4, it's going to be 3.8 times 98, which is the formula mass of H2SO4, 372.4 grams. And the last one, 36 moles, multiplied by 74, the formula mass of CaOH2, and you get 2664 grams. These equations that we've just used, these are the only equations you need to learn off for chemistry. So please, please, please make sure you know them, okay? Make sure you're confident about when you are multiplying, when you're finding mass, and then dividing when you're finding moles. I'm going to talk more about moles in the next video, but I'm just going to, if we move here to question 3, you've got 100 grams of sodium hydroxide. You've now worked out that you've got 2.5 moles. Well, what exactly does that mean? What is a mole? Mole, and in full it would be M-O-L-E, is just a word that represents a number, and the number it represents is 6.02 by 10 to the 23. Okay, so it's a word that represents a number, and that's not particularly uncommon. There are a lot of words that we use to represent numbers. So pair represents the number 2, nil would represent 0, dozen would represent 12, and now you've got mole that represents this number 6.02 by 10 to the 23. Okay, so if I give you an example, just say you were asked how many shoes, individual shoes, do you have in 3 pairs of shoes? Okay, you know that the word pair means 2. If you've got 3 pairs, then you've got 3 times 2, you have got 6 individual shoes. If I asked you how many donuts do you have in 12 dozen donuts, well, then you know that the word dozen means 12, and if you've got 12 dozen, then you've got 12 times 12, you've got 144 donuts. If I asked you the same question, but instead of donuts, I asked you eggs, if I said, right, you've got 12 dozen eggs, how many individual eggs do you have? The calculation would still be 12 times 12, and you would get the same answer. So it doesn't matter whether you're talking about donuts or eggs. If you've got 12 dozen, you're going to have 144. We can apply the same type of calculation to moles. So with NaOH, I found out that I had 2.5 moles of NaOH. If I've got 2.5 moles of something, then I'm going to have 2.5 times 6.02 by 10 to the 23. Okay, so here I knew the word pair represented 2, the word dozen represented 12. I now know that the word mole represents 6.02 by 10 to the 23. So I'm just going to do a multiplication just as I was doing above. And I'm going to do this on my calculator, so make sure you can use standard form in your calculator. It's 2.5 times 6.02 by 10 to the 23 equals 1.505 by 10 to the 24. Okay, 1.505 by 10 to the 24. When we did this with CO2, we saw that we had 1.14 moles of CO2. So just said 1.14 moles of CO2. How many molecules of Cl2 do I actually have? Well, I've got 1.14 times 6.02 by 10 to the 23. If I had 1.14 moles, I know that I've got that I must have 6.863 by 10 to the 23 molecules of CO2. When I did it with sodium, I worked out that I had 1.3 moles of sodium. Again, it's going to be 1.3 times 6.02 by 10 to the 23. And that gives me by 6.02 by 10 to the 23. And that gives me an answer of 7.826 by 10 to the 23. So the calculation is exactly the same as when I was talking about pairs and dozen. Mole is a word that represents a number. If you've got 1 mole of something, you would have this number. If you had 2 moles, you do 2 multiplied by this number. 10 moles, 10 multiplied by this number. So if we have a look at some practice questions on this. Practice questions on this. Have a go at the following. I'm not going to get you to do the really easy ones. Okay, so have a go at question 6, 7, 8, 9, and 10. And you can see that I go from asking about how many atoms to how many molecules, okay? That's because if I'm talking about sodium, sodium is made up of atoms. Carbon is made up of atoms, so I'm using the word atoms. But when I get down to water and carbon dioxide, water is not an atom, neither is carbon dioxide. They are molecules. So I switch from asking about atoms to asking about molecules. That doesn't change how you do the calculation. It's still going to be the number of moles multiplied by 6.02 by 10 to the 23. So have a go at those 5 questions now. Okay, so I've done out the answer for you there. If you've got 1 mole of sodium, then it's 1 times 6.02 by 10 to the 23. 1 mole of carbon, exactly the same. Okay, so when you had 12 dozen donuts and 12 dozen eggs, you still had 144. It's the same here with sodium and carbon. Going from sodium to carbon does not change how you do the calculation, so you're going to get the same answer. 3 moles of carbon, it's going to be 3 times 6.02 by 10 to the 23 equals 1.806 by 10 to the 24. I switch from atoms to molecules because I'm now talking about water, but I've still got 3 moles, so the calculation is still 3 times 6.02 by 10 to the 23, I get the same answer again. And then I talk about carbon dioxide, again I'm calling it a molecule, but because it's 3 moles, the answer ends up being exactly the same. So your answer for 8, 9 and 10 should all be the same because you're just doing 3 multiplied by 6.02 by 10 to the 23 each time. Okay, so by combining everything we've done so far, it is going to be possible to find out exactly how many atoms you have got in a given mass. So here I'm asked how many sodium atoms do I have in 12 grams of sodium. The first thing I need to do is go from grams to moles. So if you're starting off with a mass, you can go to moles by dividing by the formula mass. So mass divided by formula mass equals moles, and that's what I've done here. 12 divided by 23, which is for sodium, and I find out the number of moles that I've got. Once I know the number of moles, we've seen that you can go from the number of moles to the number of atoms or molecules, depending on what you're being asked about. So atoms or molecules. In this case, sodium, it would be an atom. I can go from moles to number of atoms or molecules by multiplying the number of moles by 6.02 by 10 to the 23. So if you know the number of moles, multiply by this number and you'll get the number of atoms. So once I find out the number of moles of sodium, I multiply the number of moles by the number that the word mole represents, and I work out how many atoms I've got in 12 grams of sodium. Okay, another example below. This time, because I'm talking about ammonia, I'm talking about molecules, but it's done in exactly the same way. I'm first going to find out the number of moles of ammonia by doing mass, 100, divided by formula mass. So ammonia has the formula NH3, 14 for nitrogen, 3 ones for hydrogen, gives you a formula mass of 17. Mass divided by formula mass equals the number of moles. That's going to be my first step. And then second step, once I know how many moles I've got, I multiply that number by 6.02 by 10 to the 23, and now I know how many molecules I have got. So I will leave that example on the screen if you need to have a look at it, and I want you to have a go at a few of these questions for yourself. So in each one, I ask you how many atoms or molecules, depending what I'm asking you about, are in a certain mass. For each one, your step one will be find the moles. Once you've got the moles, you multiply by 6.02 by 10 to the 23. I provided you here with the relative atomic mass. So press pause, do these 5 questions, the last 5 questions in the video, and press play when you're ready to see the answers. Okay, so I've worked out all of the answers. Each time I'm going to find the number of moles, and once I find moles, I multiply by 6.02 by 10 to the 23. So the first few should be straightforward. The last 2 here, 20 grams of water. I work out the formula mass of water. 2 hydrogens, 1 oxygen gives you a mass of 18. 20 divided by 18, and then multiply by moles. And with CH4, I've got 1 carbon, 4 hydrogens. That gives me a total formula mass of 16. And then I do my mass divided by formula mass for moles, and then moles times the number that moles represents to work out the number of molecules. When I'm doing these on my calculator, so for example here the sodium one, 500 divided by 23, when I do 500 divided by 23 on my calculator, I obviously get like a long number. When I was doing it, I wrote it down to 3 decimal places, so 21.739. But then when I was doing the next step, instead of clearing my calculator and typing in 21.739, I then multiplied that entire number by 6.02 by 10 to the 23. So even though I didn't write down that entire number when I was showing my working, I didn't clear my calculator, so it was the most accurate number possible multiplied by 6.02 by 10 to the 23. And then I rounded my answer to 2 decimal places, so 1.31 by 10 to the 25. So I would recommend that you do the same. Don't clear your calculators, keep that number as accurate as possible, and then multiply. Okay, so that's the end of this video, but in the next video, we've looked at calculating moles today, but in the next video, we're going to look at why this is useful and how this is routinely used. So don't worry if you're still a little bit unsure of moles and their use. That's going to be covered in the next video.